Hello everyone, my name is Vignesh Gopal Kalevani and I am delighted to present my research project titled Kernel-Level Rootkits in Cloud Virtual Machine, Threat Techniques and Detection Strategies. In this presentation, I will break down a very stealthy and high impact threat that exists at the intersection of cloud computing and kernel-level malware. We will explore how these rootkits work and why they are difficult to detect in cloud environments and what security strategies we can adapt to defend against them. To begin with, cloud computing has transformed how organizations manage resources. Virtual machines allow business to run multiple workloads on shared infrastructure, which helps reduce cost and boosts flexibility. But this design also introduces risk. When multiple tenants share a host system, a vulnerability in one virtual machine could potentially expose others. Kernel level rootkits are especially dangerous in this environment because they operate in most privileged layer of the OS. Once they gain access to the kernel, they manipulate system behavior, hide malicious activities, and even persist through reboots, all while staying virtually invisible. Traditional security tools like antivirus or intrusion detection system operate in user space and are often powerless against this threat embedded in the kernel. So there is an urgent need to develop smarter, deeper, and more cloud-aware detection techniques are required. What are kernel-level rootkits? Kernel-level rootkits are highly stealthy malware that runs with elevated privileges in the OS kernel. This gives them deep control over system process, memory, hardware, and allows them to hide files, processes, and network activity completely. Why it is differ from other types of rootkits? Unlike user-level rootkits, which operate in limited space and are easily to remove, Rootkits which load before the OS but lack dynamic stealth. Kernel-level rootkits are far more dangerous. In virtual machine, they can infect the OS or even exploit the hypervisor, modifying the structures like SSDT or IDT. This makes them capable of bypassing VM isolation, which poses a major risk in multi-tenant cloud environment. Vulnerabilities in Cloud VM. So what makes Cloud VM vulnerable? One example is hypervisor escape. If an attacker finds a vulnerability in the hypervisor like Spectre or Meltdown, they can break out the VM sandbox and interact directly with the host system. Another example is module injection, where attackers exploit capabilities like capsys module to load malicious code into the kernel. Shared resources such as memory or virtual disk, when not configured securely, can access unauthorized control over the VM. Finally, there is a visible problem. Cloud users don't typically have access to kernel level logs or monitoring, making it difficult to even detect an ongoing attack. Key techniques in Cloud VM. Now let's look at how these rootkits operate. System call hooking. These change how the operating system handles requests like opening a file. For instance, they can replace the function pointer in syscall table so that instead of executing a normal function, the sys runs malicious code. IDT modification. This alters how the OS responds to hardware intercept, giving rootkits the ability to mask their behavior from monitoring tools. Direct kernel object manipulation (DKOM). Rootkits can modify kernel data structures like hiding a malicious process by removing it from the active process list. Virtual machine based rootkit. Some advanced rootkits like Scout Slug operate beneath the OS entirely, using nested virtualization to intercept all VM activity without detection. This technique makes rootkit not just hard to find but also incredibly hard to remove. Kernel-level rootkits pose serious threat to Cloud VM. They can manipulate logs and traces to evade forensic analysis or even bypass security software by faking or disabling antivirus and IDS tools. Rootkits may also cause denial of service attack, crashing the VM or host, affecting other tenants in the shared environments. And finally, attackers often engage in resource abuse like mining cryptocurrency or launching DDoS attack, leading to inflated cloud billing for the victim. Detection technique and tools used. Despite their stealth, there is always a way to detect rootkits. Signature-based tools like CHK rootkit search for known file names or memory patterns. Behavior-based detection analyze changes in system behavior, unusual CPU spikes, log anomalies, or unauthorized file changes. Memory forensics Using tools like volatility can uncover hidden processes, network tampering, or kernel manipulation. Hypervisor based detection. Monitor VM from outside. Google Cloud, for example, uses VM threat detection to scan kernel memory from tampering without relying on the potential compromised guest OS. Each method has strength, but layer detection is usually the most effective one. CHK rootkit, signature-based rootkit scanner. Let's start with one of the earliest tools used for rootkit detection in Linux system. CHK rootkit is a command line scanner that searches for signs of known rootkit by checking system binaries, configuration files, and hidden files in the directories. It works by comparing the current behavior of structures of files like PS, netstack, and ls against the expected behavior. If something seems off, like missing file path or an altered checksum, it will raise a flag. Now this tool is very lightweight and easy to use, which makes it good for quick scans inside cloud-based Linux VM. However, its limitation is that it relies on predefined signature, so it is not effective against new or high stealthy rootkits. Despite its simplicity, CSK rootkit can still be useful for catching older or common rootkits and serves as a baseline protection tools in many Linux environments. Wazoo behavior-based detection tool. It is a powerful and comprehensive tool. It is an open source host-based intrusion detection system that uses behavior-based detection rather than static signature. What makes Wazoo ideal for Cloud VM is its ability to monitor logs, file integrity, system calls, and user activity in real time. It uses rules and anomaly detection to spot suspicious behavior. For example, if a system binary is modified or if a user account suddenly gains root privileges. It is scalable and works well across multi-cloud environments like AWS, Azure, and Google Cloud. It also integrated with SIEM system, which allows organization to centralize alerts from multiple VM. Its advantage over CSK rootkit is that can detect zero-day rootkit or unknown thread by monitoring behavior rather than signature. So it is more dynamic and ideal for active ongoing protection of cloud environments. Volatility memory forensic tool. Now let's look at the volatility, which is widely used in digital forensic and incident response. It is a memory forensic tool that allows investigators to examine RAM dumps from compromised VM. It helps uncover hidden processes, kernel modules, loaded drivers, and any changes made by the rootkits at kernel level. The benefit of using volatility is that it works outside the live stream. It unless memory dumps on secure, separate machine. This is important because rootkits can hide their presence from the tools running inside the infected VM, but they cannot erase their evidence from the captured memory dump. So, it is useful after the breach to understand how deep the compromise goes and collect forensic evidence of rootkit activity. It especially effective against DKOM rootkit and kernel hook tampering. Google Cloud VM threat detection, hypervisor level scanning. Finally, we have Google Cloud VM threat detection, a cloud native solution for detecting rootkit in real time. This tool is different because it operates from hypervisor level, meaning it does not rely on any agent inside the virtual machine. Instead, it analyzes the kernel memory of the VM from outside, looking for signs or tampering such as unexpected changes of memory mapping or system call tables. Because it works from hypervisor level, even if the rootkit has compromised the OS kernel, it cannot hide from the detection system. It also non-intrusive and run continuously in background. This tool is only available in Google Cloud, but it represents the future of the cloud security, where the threat detection happens at infrastructure level, not just inside the VM. It effective for catching stealthy and advanced persistent threat before they can do serious damage. Mitigation strategy. To defend against rootkits, we need proactive hardening. Module signing only allows trusted modules to load into the kernel. Minimal kernels use unikernels to reduce the attack surface. Hypervisor introspection monitor VM behavior from hypervisor layer. Patching regular updates helps prevent from vulnerabilities from being exploited. Recommended security features for cloud VM. Hardware-based protection. Isolate and encrypt VM memory to protect against kernel level attack. AI ML based detection. Machine learning models analyze abnormal patterns to identify unknown threats, improving detection accuracy. Real-time kernel monitoring system that continuously monitor kernel changes to detect rootkits and other threats before execution. Cloud VM standards. Frameworks like CIS benchmark and ISO IEC provide best practice for securing VM, including encryption and access control and compliance measures. Future work recommendation. To strengthen rootkit defense in cloud environment, we need to explore several future directions. First, rootkit honeypots. These are fake cloud VMs set up to attract and study rootkits. By observing attackers' behavior in controlled setting, we can learn how rootkits evolve. AI-powered honeypots can even detect zero-day attack by using machine learning in decoy environments. Second, AI-powered introspection tools like the concept of Rootkit GPT can monitor system behavior and use predictive analysis to detect anomalies in real time, even when the traditional tool fails. Third, better collaboration is crucial. For encouraging partnership between researchers and major cloud providers like AWS or Azure, we can combine academic knowledge with real-time infrastructure insight. Finally, promoting open source framework will allow the security community to innovate together, building customizable, transparent tools that adapt quickly to new threats. In conclusion, kernel-level rootkits are a real-time and growing threat, especially in context of cloud computing. They are stealthy, powerful, and hard to detect. They exploit kernel privileges to hide from user admins and even security tools. To defend against them, we need a combination of strong OS feature, hypervisor level monitoring, real-time AI-based detection, and collaborative research. These are the reference for my research project. Thank you. I hope this presentation gave you a deeper understanding of kernel level rootkits and how can we defend against them in cloud environment.